Hello, this is Mr. Clancy, and I wanted to discuss in this video the atmospheric convection currents. This is just for FYI, this is a revised video. We did discuss these notes in class previously, and a couple of you asked if I would be willing to redo the video, and I'm going to do that. I'm going to stay with my same set of notes. But I'd like to discuss each one as we go through. All right, so basically, there are four key factors, all right, of air, or four key properties of air that determine circulation in the atmosphere. We want to talk about these. There's also, the number four is also an important number for later, because I wanted just some applications I thought of, some interesting applications I thought would help with understanding this knowledge. So anyway, the four factors. The first one is density, the first property. Okay. The second property would be water vapor capacity. The third property would be adiabatic heating and cooling. Or cooling, I should say. And the fourth is a property of air which is called latent heat release. Let's go and discuss each of these four. The first one is probably one that we're familiar with, that density is much different with warm air versus cold air. We know that warm air rises, it's because it's less dense, and cold air falls because it's more dense. All right, so the rising will cause warm air to rise up within the troposphere and rise up. Okay, as it rises up, it cools off. As we know, as altitude increases within the troposphere, the temperature drops. All right, so warm air becomes cold air as it rises. Cold air becomes warm air, conversely, as it falls. But density differential governs is one of the key properties of air. The second one is water vapor capacity. Warm air actually has a much higher capacity for water vapor than cold air does. All right, so cold air can't hold as much water. This is to make this easy to remember. Just imagine a warm, humid day in July. Okay, there's a lot of humidity as a measure of the moisture in the air. There's a lot of moisture in the air because of the fact that temperature is so high. If it's cold, more humid, if it's cold, the cold air loses its capacity for moisture, for water vapor. And that explains why we get rain. Because when warm air rises in altitude, it cools off. When it cools off, that lower temperature air that it's now become has a smaller capacity for water vapor, and as a result, that water will turn into clouds and ultimately become rain. That's how rain forms. There is another term called the saturation point, which is important to remember, and that basically characterizes the maximum amount of water vapor that can be in the air at a given temperature. So the higher the temperature, typically, the more water vapor maximum can be in the air at that time. The third factor is called adiabatic heating or cooling. And maybe you know that as air rises in the atmosphere, it cools off. As air falls from the upper atmosphere to the lower, it warms up. But maybe you weren't sure why this happens. This phenomenon is called adiabatic heating and/or cooling. So let's talk about adiabatic cooling first. The air rises. This is hot air rises in the atmosphere. Again, it's less dense. It's going to encounter lower pressure air surrounding it. The pressure up top, the pressure in the upper part of the atmosphere is lower than it is in the lower part of the atmosphere. Because the surrounding air pressure to this air is lower, the air that's rising actually expands. And this expansion that it undergoes leads to cooling. So that's called adiabatic cooling. The converse for this block of air is also true. When this air is cooled off up top, it's going to be dense, and now it wants to fall. When it falls toward the earth, all right, it's going to incur higher pressure. When it's higher pressure, it's sort of squeezing that block of air. If it falls, the higher pressure surrounding air will force that air falling within it, if you will, to heat up. The fourth factor is called latent heat release. And this just refers to the heat or the energy that is released from water vapor when water vapor condenses into a liquid. So rain's forming, all right? You're going from the water vapor is going from the gas phase, if you will, to the liquid phase. There's going to be some heat released. That heat released goes into the atmosphere. It causes the air to warm, and warm air, we know from point one, is less dense than cold air. So that lower density air is going to rise. So now those are the four factors: density, water vapor capacity, additive, and latent heat release. Now the other four I wanted you to think about, as we mentioned, are four applications. One application I thought about is an air conditioner at your house. Hot days, it's nice to have an air conditioner. It keeps the house nice and cold. The air conditioner does two things. All right, it cools the air, and it removes the humidity. When it removes the humidity, that water has to go. You'll have a white pipe that drains from your air conditioner. It could be inside your house or outside your house. Ours is inside our house, and the white pipe goes into our slop sink, so it goes right down the drain. There are some people who have an air conditioner outside their house, so they use this dehumidified water, or the water from the air, if you will, that's been taken out of the air, to actually water their plants and water their garden. So that's a pretty cool application. The second application has to do with why leaves fall in the autumn. In the autumn, certainly I think it's my favorite time of year, in the autumn the temperature starts to drop. When the temperature drops, the air has a lower capacity for water, as we mentioned earlier. So the transpiration rate, all right, of water, remember transpiration is water that goes up from the roots of a tree. I'll draw a little easy tree here. I mentioned this in class yesterday. Here's my tree. And the water goes up in the roots, through the roots of the tree. The roots suck it up. It goes up the narrow, what are called xylem in the tree. And basically the path of the water goes up and out to the atmosphere. All right, this is called transpiration. What transpired. Transpiration. This is why trees are terrific at controlling floods. They're wonderful at controlling erosion. They sort of suck up the water and allow the tree to, or allow the water to basically evaporate back into the atmosphere. It evaporates through the leaves. So during the autumn weather, when it starts to cool off, the tree adapts to the lower temperatures and the drier conditions by ultimately shedding the leaves. So the shedding of the leaves actually lowers the transpiration rate. A third application is topography. If I have a mountain range and I have some, you can see I've got a picture of some high moisture laden air that comes in from left to right. It encounters this mountain range and is forced up. All right, it's forced up in altitude. When it does get forced up, the temperature drops up here. Temperature drops as it encounters because it's going up in altitude, which ultimately causes precipitation for reasons that we mentioned earlier. This precipitation is often on the side of the mountain or the mountain range that faces the wind because of that reason. As the wind goes up away, at this point, there is no more moisture. It's much drier air. And as a result, there's often no precipitation on the backside of the mountain or the mountain range. So I thought that was another cool application. The fourth application is how hail forms. What makes hail form? We see hail here. Maybe you've heard it in your house, pinging on the side. What happens? How does that form? Well, during very warm weather, we've got formation of rain, and we've got warm, moist air rising. All right, so that warm, moist air is going to rise. And it's going to rise up from the earth. It cools off, and subsequently condensation occurs and rain forms. So it cools and rain forms. When this rain forms, it's falling toward the earth, but underneath it, because of the incredible hot weather, is this what's called high temperature updrafts. All right, which basically force this rain back up in altitude. It gets forced back up. That rain refreezes into that form what we've known as hail. And when the hail is big enough and heavy enough to kind of fall through these updrafts, it will fall and hit the earth. So it's kind of an interesting phenomenon. You may have seen some very large hail, especially in places like Oklahoma and Kansas and places like that. We usually get much smaller hail, but I've seen some as big as even as golf ball, even baseball size in some situations. So anyway, so those are the four properties of air that characterize atmospheric convection currents, and also four applications of that. Thank you very much.